What is up, everybody? We are back this time in less fancy dress, less costumes, but Justin and I are in matching tops. I know we said reinvent, but I didn't realize we had the same shirts. That's pretty cool. But Justin, how are you doing today?
Doing all right.
Good. And Justin has a very funky background like me. We had a long call. We were supposed to be practicing for our reinvent session, but we just went through each other's backgrounds. I really like the light thing that is like going off behind you. What is that?
It's a set of Govee lights, I think, that I picked up used in the neighborhood. They're great. I like the cubes. They remind me a lot of like our backgrounds and stuff we use in our decks. So
yeah, they're very Amazonian. I just assumed that they were. Love it. So one thing to plug before we get started is we are going to be talking at reInvent. Justin and I have a code talk that we will be doing, which is a COP 403 Advanced Analytics with Cost and Usage Reports. It's going to be really fun. We've got 4 queries to go through, a lot of information about the CUR, and also hopefully a good time. If you went to my code talk last time, you might remember there was a bit of a challenge going on with errors where there'll be a forfeit of some kind, and that is going to be happening again this time. But Justin, what's your favorite part about reInvent as a small snippet?
So I did that same shirt, reInvent 22. I mean, replay is always a blast. In previous reInvents, I participated in Deep Racer. So I helped run some of the races. Those were super fun. And really just spending some time with my customers and other people who are super interested in the same stuff I am, right? It's crazy to think that there's a number of people who want to come watch us write CUR queries, but I spend a whole lot of time in CUR, so I'm excited to share some of that with folks who are also CUR enthusiasts.
Yeah. Which is a good segue into the show. So let me do the intro. Welcome everyone to the Keys to AWS Optimization, the show where we share stories, concepts, and solutions to help you unlock your spend at AWS. My name is Steph Gooch, a Senior Optimization Architect, here to help you with all your FinOps questions. And we are going to be talking about EBS utilization and connecting using IOPS, something that this specific topic hadn't heard of. Justin and I were chatting about queries we could do at reInvent, and he was like, oh, I have this thing. And I was like, this is really cool. Why don't we just do a Twitch episode on it? Because I think it's more involved. So we are going to be doing some CUR querying stuff today. There'll be some other highlights and bits and bobs going throughout, but one other thing is if you are going to FinOps X Barcelona, FinOps X Europe, I will be there. I will be at the Amazon booth. Come say hi. Tell me some of your FinOps challenges. Tell me some things you've done in FinOps. Would love to hear that from you guys and excited to meet some people who watch. And also chat. Let's get involved. Hi, everybody in the chat. Costlayer in the house will be at the talk at reInvent. Thank you, Costlayer. Okay, let's get into it. So, Justin, let's hear your 1-minute origin story. Tell us all about who you are and what you do at AWS.
Yeah, I'm a senior technical account manager. I get to hang out in Pittsburgh all day. I love the city. I'm a native Yinzer. You'll find me on the south side. In our office, we're down there by Hofbrauhaus and a couple of other places. I've been at AWS for about 5.5 years now. On the enterprise support side, helping some of our biggest customers deal with some of the weirdest and most interesting challenges that they bring to me. Every day is a little bit different. Cost has always been part of the conversation for me. So I started spending way too much time writing CUR queries, understanding the data, and trying to figure out ways that it can help customers kind of do what they need to do, be more informed. And kind of that's why it's part of why I'm here today, right? Talking cost. I am a CFM, Cloud Financial Management Specialist here at AWS. Run a lot of cost op workshops for customers, and I think at some point we're going to plug the CUR query library. I am also
already got it up on there. Almost ready.
One of the maintainers of the CUR query library. So if you have checked that out, appreciate it. If you haven't, definitely check it out if you find yourself poking around in Athena and trying to get started with understanding your costs in there.
Yeah, we love the CUR query library. I use it all the time, especially just to get me started on a query. And I feel like I like to do a shout out as well. So let's get into the this concept of this. We called it misalignment as well when we were discussing it, and how you effectively use your EBS cost. But do you want to give a quick overview of this whole thing, and then we'll start to dig into some of the weeds?
Sure. So EBS is block storage for your EC2, RDS, and other various workloads at AWS. And when we think about optimization for EBS, this could be things like making sure you're not over allocating your storage, making sure you're tuning things like your IOPS or your throughput to match your workload, right? And just general like right sizing concepts. The interesting piece about IOPS is, we have a number of different volume types out there. And for a handful of them, particularly GP3, IO1, IO2, those volume types allow you to set your own IOPS, your own like maximum IOPS levels. And while a lot of the conversations we have are around right sizing, the problem that I planned on talking about today was actually has nothing to do with how much of it you're using. It is purely an opportunity to optimize and either scale down your IOPS if you've allocated so much you can't even use them, or scale your workloads up into the IOPS you've provisioned so that you can actually take advantage of them.
Yeah, so this isn't necessarily about saving money in an exact of like getting rid of something and resizing it. It's more about using what you paid for, which I think is a very cool finding. So let's level set. Let's bring it down to, Justin, what are IOPS?
Yeah, for sure. So out there in our EBS documentation, IOPS are they're input-output operations. And when it comes to disk storage and block storage, we're talking about 256 kilobyte writes or reads. And really, there's some math behind it to figure out like how many IOPS a certain operation has. It has to do with how serial a read or write might be, sequential it might be, if it's random, etc. But essentially, it's you moving bits across the pipe between EC2 and EBS to move stuff in and off of disk.
Perfect, nice and simple. So what exactly, you kind of hinted at it, but let's lay it out. What is IOPS misalignment?
Sure. So I know misalignment is not necessarily the word that we like to use, but that's how we've been kind of describing the problem on our side. So there's this concept of EBS optimized EC2 instances, right? And they have certain characteristics about how that connection between EC2 and EBS, right? How much bandwidth it has, how much throughput it has, and how many IOPS it can carry. And because we're focusing in on IOPS, there is a maximum IOPS that channel can handle. And if the interesting thing is you can, in EC2 or EBS, when you're creating a volume, you set those IOPS separate from the EC2 instance, but the EC2 instance may actually have a maximum IOPS that it can support. And there's a chance that you provision too much expecting to get to those IOPS, but you'll find yourself throttled at that EC2 like connection layer before you even get a chance to try to use them all.
Yeah, and John in the chat is saying maybe realignment is what we should be calling it. That we need to do that realignment. And also, just to shout out, we have some love for the Kirk query library. They'd like some more advanced metric queries. That's some feedback. Feel free to, do you know what, if you have that kind of a question, guys, you know what you can always do? You can email us at costoptimization@amazon.com. And also, I haven't even said, if you're watching us on YouTube, then don't forget to like and subscribe. And if you're watching us on the Twitch channel, hit up, there's so many amazing shows on here. Don't forget to hit that subscribe button. But back to some of these comments. The query library is the best. I 100% agree. Helped create it. I'm always biased. We did the FinOps draft, and Savannah was like, "Did you just choose everything that you made?" And I was like, "Yeah, I'm good at my job." No joking. Anyways, so I love this description, and we have some documentation to show you of where you can actually see this kind of thing. But I wanted to draw down, Justin, into where you first saw this. So there was like a customer that kind of made you notice this, and we're going to discuss like what happened at the end of the episode, so make sure you stick around. But what made you start looking into this?
Yeah, earlier this year, I was working with a customer on a database issue. One of their really critical databases on RDS was having disk latency problems, and we were really struggling out of the gate to figure out what was going on because some of their business metrics, some of their like disk latency and stuff, those metrics were all spiking, and we knew there was an issue. And then whenever we would go check out, how are your IOPS looking? And they had what we thought was more than enough IOPS to deal with the workload, but kind of that hidden piece was the instance type and size that they had picked for the RDS instance was actually throttling the IOPS, right? That's what was getting saturated. And it wasn't immediately obvious. So after spending some time with them, digging in and finding that out, that's kind of where I landed on this little nugget of information.
Yeah. And quick poll checking, guys. Did you know that EC2 have a limit of IOPS they can max out on? Because I definitely did not know this. And that's why when Justin, I didn't know. Sorry, that's wrong answer. So 1 for yes, 2 for no, if you did or didn't know it. I had no idea that this was a thing, and it wasn't until we started discussing it that I was like and I can see John's here, and maybe he knows about this, and I'd already mentioned it to Andy, who was on last week, and they were like, yeah, and I was like, how did I not know this? So I feel like I'm in the minority as shown by the graph as well. But there, some people did, some people didn't. So hopefully from today's episode you will learn a little bit about it. So Justin, let's go into some of the demo stuff in terms of showing the documentation.
Sure.
Costa says everything has a limit. If you follow Mean Girls, the limit does not exist. So, media quote. Okay, I'll show your screen.
Sure. So out here in EBS documentation, in EC2 documentation, rather, we have this section called EBS Optimization. And this is where you can see some of these tables. Once you scroll down enough, you'll see the groupings by like instance, like family, right? General purpose, compute optimized, memory optimized. And in these tables, all the way over on the right, you can see both baseline and maximums. Baseline is not particularly important for this conversation, but it's there in case you have, instances that support kind of bursting into higher performance tiers. For the most part, though, we are laser focused on maximum IOPS, and you can see each of these tables gives this maximum IOPS value for each instance size that we have out there. Mm-hmm. So this is the piece of documentation that I stumbled across to kind of help explain the issue my customer was seeing, where maybe they had 25,000 IOPS provisioned on a volume in this case, but their instance only supported 20,000.
Right. And at the moment, there's nothing that stops you from over provisioning of what these EC2s can take, right?
Not that I've seen. So there's nothing, no warnings, no like checks that'll tell you, hey, you've provisioned a little bit too much than what is supported with your instance. That's not to say that it's not flagged in other ways, right? If you're not using those IOPS, then it might pop up in Cost Optimization Hub as a finding, or Compute Optimizer. But we can show a little bit of that off too. But it doesn't necessarily highlight this optimization opportunity.
I mean, we can show the Cost Optimization Hub now. That'd be a good little segue into it. And I'll do a bit quick spiel. So if you don't know Cost Optimization Hub, a place that collects all of your recommendations, prioritizes them and groups them together. And it also looks for ones that kind of overlap. So people ask like, oh, if I have a savings plan recommendation and a turn off and a right size, like how do I balance those out? And this will do that for you. And it'll prioritize the one that's going to be the most effective for you. But you can also decouple these and prioritize yourself, but it does some of the logic for you. So at the top there, you can see group related recommendations as a little toggle. So they're all together. But if Justin untoggled that button, it would expand the list to multiple ones for the same resources, like those EC2s have 2 now. But yeah, let's go for you showcase the EBS ones.
And of course, you can see my wonderfully named resource ID here, over provisioned IOPS. So this was part of my test. And actually, the second volume here is also part of the testing I was doing to show this today. And you can see that it is calling it out that, hey, we need to do some right sizing, both on this EBS volume and on the RDS volume. And it gives you a summary of what we currently have provisioned. You can see in this case, I have 20,000 IOPS, and in this case, I have 25,001 IOPS, and what it recommends. Now, these recommendations are going to be based on your usage, right? So your usage pattern is going to drive what these recommendations are. But what you aren't seeing in these opportunities is that the fact that you over allocated IOPS means that you're never going to reach the levels that I've set here. So there's again kind of like a more immediate and a little bit more hidden opportunity here, where you can either tune your IOPS to match the instance if you actually don't need that many, or go right size your instance up into a class that into an instance type and size that will support it. So if you needed this 25,001 IOPS, you've worked with those teams to determine that. Coming right back to the documentation here, we can scroll over here and figure out like, oh, okay, if this was theoretically an M4 4x large, but you need those IOPS, maybe it's time to up it to an M4 10x large. So that's kind of another way to optimize here more operationally.
Yeah, and it's having that conversation, and I'll say it's now for a sec, but it's having that conversation with your application team is something we spoke about, where this is a perfect example of when it's not the FinOps team's decision to make a change of something. This isn't the same as like an idle EBS volume that you've seen unattached and zombied for ages. This is more of there's something that's kind of like misaligned and needs to be a decision made. Do you actually need those objects? Like that classic question I always love to ask people, do you need that? But if they're like, no, we do, and like Justin's example at the start, their customer did need those IOPS, then you have to resize and you have to kind of spend that more. But for the performance of your overall application, that is what the business needs. And so it's understanding that kind of balance. But we love always talking about customization hub. So who's tried it? 1 for yes, 2 for no. I bring it up in my presentations a lot because people didn't know it was there. And I just like the centralized location and the different effort levels. We have that on Compute Optimizer as well. But I do always really enjoy kind of showing people that, especially because it's part of data exports, which our reInvent talk is going to be about. So make sure you come to that if you're coming to reInvent. Last year, someone bought me, okay, so everyone's tried it. Okay, we're on the same page. Last year, someone bought me some M&Ms when they came to reInvent. I hadn't tried because I love M&Ms. So if anybody wants to bring me some M&Ms this year, like, I'll happily take them. Just a plug. Anyways, right. So we've kind of showcased the kind of what IOPS is and what this problem is, but we want to start making sure that we avoid it. You're also going to call out the RDS doc. That was the other thing we were going to showcase, right?
Yeah, just real quick, I think it's worth mentioning that the documentation here for these EBS optimized volumes and the characteristics here for maximums is in EC2 documentation, but you don't get these like big glaring tables that you can't miss in RDS documentation on the same. But there is a call out here. So if you're looking through RDS documentation, you're digging through instance storage, you can see all the way down here towards the bottom, like some things that affect database performance. They do call out instance class as a factor that you need to consider. And this big red box in the middle here is telling you, hey, go check out that EBS that EC2 EBS optimized instances documentation, because this can happen, right? They call it right out here that there's a chance that you'll see lower IOPS performance than what you provision. So that's, again, kind of explicitly the problem. And again, this is what applied to my customer in that one situation. So
yeah, well, let's get on to how do we actually see this and use some of that querying that we love talking about. So we showcase Customization Hub, but let's go through the whole process of like finding these EC2 instances and then using some data to pull this in.
Okay, so if you have 10 instances, which I don't know how many people on the call watching the stream today or watching the YouTube will only have that many instances, but I mean, you can come and poke around in the console and try to figure out, you have this instance, it has this attached volume, right? And even from here, you can't necessarily see the provisioned IOPS you have, so then you have to go down into the volume, and then you can dig in and you can see how many IOPS you have provisioned here. Again, this is where kind of like those things are decoupled, right? You're creating volumes independent of your EC2 instances. So going through here and trying to figure out like which ones have how much IOPS provisioned, or even if you're poking around the APIs, can be a little bit tough too. So what I prefer to do to at least kind of get a handle on those tables, and no, I would not recommend you go out into documentation here and try to copy and paste these into Excel. It's not going to be a good time.
He's tried it.
I'll admit that I did make an attempt. We do actually pipe this out from described instance types on the EC2 API. So with the right query and the right filters, you can actually get this in JSON format pretty nicely. And I'm being lazy, so you don't see all my typos. But here's the command that you can run today in the AWS CLI. Right, you're going to describe instance types, and we're going to be looking for like the instance type, the max bandwidth, et cetera, and we're going to filter just down to those EBS optimized instance types on that page that we showed, and we want the output in JSON. So whenever we run this, you're going to see that we'll get a JSON response here with all the data that we need. I mean, this is great. Now we just need to get a full inventory of all of our EC2 instances and all of their attached EBS volumes. Like, it's super simple, right? So this is where I kind of turned my head towards not trying to reinvent the wheel and just using something we already have out there. So I don't know. Do you want me to talk about this part, Steph, or do you want to?
I can cover the data collector. Yeah. So we talked a bit about it many times, actually. I say like 2 weeks ago. But the data collector is something that stemmed from something I made years ago and has grown massively, which is amazing. So the idea is you have your FinOps centralized account, and we deploy it. I think it's the architecture. We deploy a rollout to all of your linked accounts, and we use that to extract data. So that data is things like your compute optimizer recommendations for the compute optimizer dashboard. It could be just advisor recommendations. It could be your organization account names, which we used to have to do before Kerr 2.0 had them. But also it has inventory data. So we are pulling in EBS information. We're pulling in AMI, snapshots, EC2, RDS. If you've used the Graviton dashboard, some of that is from there. So what it does is it pulls all this information using CloudFormation and Lambda functions and step functions into a singular bucket, all nicely partitioned and named. And then what you can do is use Athena to query it and connect all these different data sets. So the goal is that there's actually so many modules now, classic with CID. There's so many things in there. You don't have to select them all, but you can choose things that are relevant to you and start inputting this data, and it runs every 2 weeks. And you have this basically data lake of information you can use to optimize. So one of the things we're going to be doing in our reInvent session is looking at AMI snapshots that come from this data. But in here, one of the things that was added more recently was an inventory of all the EC2, because the cost and use report, which is often a FinOps practitioner's main set of data, does not have the details that you need for the configurations, which is why we've gone for it in here. Did I miss anything?
No, I don't think so. But this is where I turned to try to get some of this inventory data, because hey, they've already done it and it works really well. Should I launch right into the querying and stuff, or where should we go?
Do you want to have a look at the data that's actually in the table? So especially
Yes.
the kind of EC2 stuff and the EBS side, so people can see the stuff that's in there.
Yes. So let's hop over to Athena. This is one of our accounts where we have the collector installed.
It's
right?
Justin's super secret account.
My Justin's super secret account number. Yep. So before I spoil what I did there, you can see in the optimization data database that gets created, there's all these inventory tables, and this is all of that data that Steph was kind of alluding to. And we have both instances data and volume data for EBS. And you can click in here and just preview these, but I already have them open. So these preview queries are going to give us just an idea what's out here. So this is the one that I worked on. Here's our instances data. So out in inventory, you can see that we have things like which AMI it used for its image. We have the instance ID and we have the instance type. And these were the two pieces in particular that I was interested in for this query. I need to know which instances are which size, right? And then I need to find a way to join this up with which volumes and their IOPS values are attached to which instances. So turning over to EBS data, and I'm just going to preview this one so we can see it without all of my modifications. And you can see that we have this array called attachments, and inside of that array is a JSON map, and it does have instance ID in here, so we can track which volume IDs are attached to which instances. So those are kind of the pieces that I need. It also has other information in here, like the storage size, the volume ID, and then this IOPS field is also, this IOPS column is particularly interesting because this is going to show me how many IOPS I've provisioned for it.
Handily. And we've already had a question, which is from Crosslayer. Is this particular query in the query library? We knew someone would ask this, and the answer is it's coming soon to Optimization Data Collection EU.
So it's, yeah, we're working to get this added to the data collection. Is it in the query library? That's also a really good question. Up to this point, CQL, as I like to shorten it to, has been, it's been hosting legacy Kerr queries. And if folks have been visiting it more often, you might have noticed we've been putting Kerr 2.0 and maybe a focus query here or there to just give folks a jump start there. We are starting to think about how we can add more metrics and operational data. So there's definitely an opportunity for us to consider some of the more advanced, like additional data set type queries. We are thinking about it.
Nice.
I can't make any promises on when it'll show up though.
There's also, just to shout that out, I'm just gonna I was just gonna say that we can now move to Kerr 2.0 with the Cloud Intelligence dashboards. I know a lot of people who watch this show love the Cloud Intelligence dashboards and utilize them. You can now move to Kerr 2.0 with it. So there's a whole set of information. If you check out my LinkedIn, if you follow me there, or in all the show notes, if you're watching us on YouTube, and obviously you've subscribed, you will see that down below there's going to be all the links about that too. But yeah, so with that data, Justin, we need to extract some of this information, right? And one of the things we were talking about is that array. The method you're going to use, I had not seen before. So do you want to explain how you extract that kind of information?
I want to, can I take a quick sidebar and show, I want to show the data, the EBS maximums data and how we got it into here too. So let's finish getting the data sets into one place. So, you know, we ran the, this query, we ran the CLI command and we have this JSON map. And I will admittedly, I'll openly admit that I went through and kind of transformed this file by hand to make it work as part of my proof of concept. But you don't have to redo that work. We have it out here. So essentially I had to flatten it and remove the commas and turn this into like one big like JSON column, let's say, right? It's going to interpret it as one column, a JSON map with key value pairs in it. And this is what it looks like after you get it all done. And hopefully this is very similar to what it would look like once we get it out into, if and when we get it out into the data collector.
Yeah, and if you want to mess around with it, the link I just put in the chat is to get this file. So it will open up this kind of page for you, so you can copy that into a file and try it in your own Athena, or wait until the optimization data collector releases it.
Yep. So I also took that data, threw it into an S3 bucket. I kind of copied a lot of the Lambda stuff that does the inventory that, you know, needed to be pointed to the new data that I put out there. And you can see that when I preview here. Ignore this name. It's not final. I actually put an additional inventory underscore prefix on there.
Inventory.
And there may also be additional columns in here based on projected partition columns and stuff that may not end up in the final thing. But here we are. We preview this and we can see all that same JSON data, but now we can work with it in Athena, right? We can see.
And this is basically the same as what was on that website as well, right?
Yes, it's exactly the same as what's in that website. Yep. So you can see maximum IOPS. This is what we're kind of focused on today. So now that we have instance ID and size, and then we have EBS, volume ID, IOPS, and instance that it's attached to, and now we have instance size and max. We can kind of squish all this stuff together. You can see where it's going to land on what we did to find where these kind of misalignments or these optimization opportunities are. So I'm going to take this piece by piece. I'll save you, if you want to watch me write queries, come show up at our reInvent talk.
But not today. We're not doing it today.
Not today.
We'll do, chunks.
So kind of this, let's walk through this first one here. We can see that we're grabbing, again, like EBS account volume, attachments. So this is that array with the JSON map in it. And inside of that, let me see if I can find the array again. So if we take a look again at, here I am just jumping around. It had to be this one. Okay, EBS data. So when we take a look at this data, it is an array, and there is a chance that EBS volumes can be attached to multiple instances, right? So we're going to want to make sure we handle that, right? We don't want to report out on places where volumes could be attached twice, because maybe you do need more IOPS in that case. So we're going to build a filter in for that. You can see in here that we need to grab the first attachment, right? If it only has one attachment, we have to grab the first one. So we're going to dig into this array for the first value, and then we're going to use dot notation in Athena to extract the value of instance ID. So let's go back to our EC2 query or EBS query here. So you can see we have EBS. We're getting to the attachments array. We're grabbing the first value. Don't drag that around. And then we're using dot notation to grab instance ID. From that, we're first going to...
Can I drill down into that just to double check?
Yes,
so
sure.
The EBS attachment is that first column, and then the first one in that array is the one,
right.
And then the dot instance ID is of all those key values, the thing equals, you want the instance ID to return. Yeah?
Yes. Perfect. So, and you can see we can run, let's just highlight this whole thing. If you didn't know, in Athena, you can highlight subsections of queries and run them. So we don't have to run the whole big thing and spoil what it's going to look like in the end. So you can see here that we're going to get a list of the accounts, the volumes, the instance IDs. It's going to extract that instance type from that array and that key value. And it's even going to show us things like volume type and the provisioned amounts that we can pull out of here. So honing in on provisioned IOPS, you can see most of the stuff looks pretty solid. This isn't my big crazy instance, but there are 349 results. So let's take all of those. Well, I guess the other piece that I want to call out here is in my where. We are using cardinality. So this wasn't a common function in my repertoire before I started digging into this. I actually had somebody bring a query to me the other day that started using it. So then I was like, how is this useful? And just hopping over to docs real quick, Athena version 3 uses Trino functions. And if we hop down into Trino docs here, we can see cardinality. Whenever you're working with arrays, this is going to tell you the size of the array, essentially. And that could be helpful whenever we have arrays of data, and we want to make sure that there's only one instance of data in there. So again, when we're looking at EBS data, we said we wanted to make sure we filter out EBS volumes where they're attached to more than one instance. This is how we do that. We only want to see, we don't want to see detached volumes, because that's not a problem here. We won't need to do anything with max IOPS tuning there. We only want ones where they're attached to a single instance where it's easy to compare. So that's what this query is doing here. And again, I think we're going to provide copies of this stuff at some point. Of like the queries, so don't feel like you need to screenshot it or anything. And then after we get this this result set that we have down here, now we want to we're going to join our maximums in here, right? So our data set so far just shows us volume instance, the type of instance, and then how many IOPS we provisioned. And now we want to compare that against those maximums that we pulled in from that API call. So in here, we're going to add maximums, right? Maximum IOPS, maximum throughput. And we're going to join our goofy maximums table that I've named here onto that data set where the instance sizes match exactly. And then we're going to do a quick filter. And actually, I'll run all this without that filter so we see what we can get.
Ooh.
So
live querying, and it works. Yay.
Yeah, so we still have 349 results, but now we can see in here that that we have our maximums aligned in here, and we can see maximum IOPS, maximum throughput, and then we're going to add this where filter where we want to see where we've provisioned too much IOPS for the instance things are running on, and we should only get one result. So this is my over provisioned test instance. I created the C5 large with an IO1 volume, and you can see that I provisioned 25,001 IOPS when this instance size only supports 20,000.
And can we go validate your findings? So if we go onto the website, is the C5?
It was a C5 4x large, right? I'm gonna check.
I'm like, I do not. I'm assuming
C5 large. C5 large. I think it's the same though. Let's do. Oh, so C5 large is right here, and you can see it maxes out at 20,000. It has a baseline of 4,000, but it can go up to a maximum of 20.
And Justin silly provisioned 200, and I can't remember the number. A much bigger number.
5,001 additional IOPS than I needed.
Go on, sorry.
I say, and that's not insignificant, right? If again, in the case of my customer and their RDS situation, they could have, if they worked through it, like, hey, we can save 5,001 IOPS worth of cost, and let's see, I should have the. Do I not have the pricing up here?
The pricing.
Oh, here it is.
Good.
So ABS pricing, if we just hone in on USC Swan, where everybody is running stuff, you can check out the pricing and get an idea. And I could bake this into the query too. I didn't have the 5 minutes to do it before we presented today, but you can see here that for like IO2 volumes or IO1 volumes, you're paying 6.5 cents per provisioned IOP per month. So, back the napkin math, 6.5 cents times 5,000 ends up being a not insignificant number.
We just had a good question. Let me just pull this up. Hey Justin, any PFRs to add guardrails to not allow over provisioning IOPS? Do you know if there are any? If not, we'll make one.
I recognize the name. Hey Tim. No, I don't know. I'm not sure, but this is a message that I'm working on, getting in front of all the right folks. So hopefully soon.
Well, if you know Tim, we'll make one, and then we'll add him and his company to it.
Yes,
for sure.
Right.
Because we love a PFR. And as a reminder, guys, you can make PFRs without us. So if you go up to support and there's feature requests as an option, I now found where those go. So I'm looking out for you guys if you're raising them. But provide any features you can, or ask your account teams to raise one for you in the system. But we love to hear it. We want to know what you guys want us to build. Okay, sorry, where did we get to? So we just saw that the pricing, like I said, it's not insignificant. All these things do add up, especially when you think about this at scale. So if I just to touch on that for a second, like if that how much was it, like 1,000 a month, what we were talking about earlier?
Yeah, it was let's see. Yeah, it was about 1,000. I think it came just short of 1,000.
Imagine that's for like one instance, or is that for all the instances?
It was for one database. Yep.
One database. So that's like, okay, this is the same as like Elastic IPs, but a little bit more. If you have that in one account, then you're like, oh, that was a silly mistake. But I don't know about you guys, and this always goes from my personal history. When I used to develop, we would use the same templates like over and over again, those Terraform modules that would have defaults in them, that would have a kind of chosen EC2 instance that we always used because we were buying RIs at that time before savings plan. And the IOPS was like pre-configured, and it was just kind of a baseline. Unless anybody came and told us, no, you need to change because we need more or less, we would just leave it to the default. But if the defaults are wrong in terms of like our defaults, then we will be wasting money, not just in one account, not just in 3 test, prod, and dev, in like hundreds of accounts. So I really encourage you to go and have a critical look at your accounts and see if you've done this anywhere, and make sure none of your defaults align to this. That would be a kind of good way of protecting your scale.
Yeah.
Okay. And
Yeah,
you wanted to also show the RDS one, right?
Yeah, let's just touch on that real quick. Again, you can apply this same, this same problem applies to RDS and the storage that you provision for your RDS databases. So you can see this is me previewing the RDS DB instances data inventory. And you can see out here, very similar to EC2, it's going to be slightly different. We have to deal with instance class having a DB prefix, and let's see what else was in here. You can see there's all kinds of like really interesting data that you can kind of poke and prod. Whenever we take a look at the query that I ended up coming up with for the RDS one, it's very similar: account ID, DB instance identifier, and the instance class. But again, remembering that the instance class has that DB prefix, whenever we do our join here between our maximums, we're going to join instance class. And then I ended up just concatenating a DB dot onto the front of it, because that seemed like the easiest way to get it to line up. And I also did some filtering here to make sure that we're only checking storage types where IOPS is configurable, right? We wouldn't want to be checking this on GP2 because you don't have the options to change that. And again, this should return one result for my bad database here, where I've over provisioned some IOPS on an M5 large. You can see that we've provisioned 20,000 IOPS, and this only supports 18,750. So again, when my customer, when we found this situation, they instead of just going and turning the IOPS down, which they could do with little to no risk, right? You can't take advantage of those IOPS you provisioned. You could probably pretty quickly scale down to the max, but they had to, because they were in an operational situation, that database was having performance problems and it was affecting their customers. We had to make that quick call to scale up from an M5 large to another size or two up until we hit a maximum that was higher than what they provisioned.
And with you mentioned the GP3, we talked a lot about optimizing like GP3 because that provisioned line. So does that mean, to clarify, that in the previous example with the EC2 instances, that the GP2 is the same, that if you had that, you would filter out those ones?
I probably should have filtered it out here. It's probably not a bad call. I think I ended up I wrote these up pretty quick. So yeah, this is this is a reasonable filter. If it probably is worth adding up to the top here, filtering out EBS volumes.
I wonder if like by default, because you can't change it, with like the equations in there would allow you to kind of like, if more than the greater than, would kind of filter it out anyway. But always good to be specific, because you can't change those things. Because remember, there's things, especially with GP3, people forget that if you're anything under a terabyte, then it is 20% cheaper, like for like. But if you're over a terabyte, that's where these provision IOPS start to become a little bit iffy, where you have to start to consider what you actually need, because there's a is that, oh, now my mind's going, is it a 3,000 base on GP3? I think you get them with like without doing any configuration, whereas GP2 is scalable. Anyways, anything else you want to showcase on this?
It is 3,000. You're right. I wanted to confirm.
I was like, I've said that as and also that came out like how many years ago, and we're still talking about GP3. And there was a real moment where I was like, at 3,000, it's like I still remember certain percentages from my psychology exam in my A levels, and it's like I think those are right, and I'll Google it. I'm like, yeah, still got it.
No, I don't think I had anything else to show off today. I think all this practice of Kirk query presentation ahead of our reInvent session has me talking a little bit faster than I normally would. So
yeah, we have to scale stuff. Well, one more question, guys, in the chat. Will you look at your EBS provision volumes versus your maximum one? I expect everyone to be saying yes in the chat. 1 for yes, 2 for no. But we've got like 2 more minutes before we're gonna wrap up. Anything else that we want to cover? But But yes, people are saying yes, this is what we want to hear. Make sure that everybody is moving over. 1 for yes, 2 for no. But yeah, I think that was, like I said, very fascinating to kind of bring this up where I'd never even heard of this like provisioning thing, or like I said, scaling at it. And Costa says, please provide the Athena query. What I'll do is I'll put this in an S3 bucket and make it shareable with that other file. So just watch out for the show notes. They'll be in there. And like I said, all those show notes are on YouTube. So if you're watching live, welcome. Don't forget to subscribe to our YouTube channel, Keys to AWS Optimization. But one more thing I wanted to cover was mentioning this CID guide to deployments. I'm just going to share this up here. Of course, let's pull this up. But have you had a chance to look at any of the CID stuff for GP3, GP2, GP3? No, what am I talking about? It's CAD 2.0. I can't. But this is quite exciting. So I've been pushing for a while. This is brand new announcement like 2 days ago. So you can now utilize CAD 2.0 with the Cloud Intelligence dashboards. So you can either, for new customers, you can use it straight away. We also have a kind of update to get 2.0. Or if you want to keep legacy and then have like a proxy over the top, or vice versa for any processes, the long and the short of it is everything you need is in this website, which I will share. But it is super cool. Obviously, Justin's, we've dove right into the CAD 2.0 stuff quite a lot. And Kelsey says AWS is awesome, which we love. But of the CAD 2.0 stuff, what is your favorite of the kind of big changes that it has? Curious.
You're spoiling my slides for reInvent.
No, just one.
This isn't like hidden data. Right? Kirk 2.0 is already out there. Let's see, my favorite. I've talked with a lot of customers about cost and usage reports, and maybe not the one that I'm most excited for myself, but what I'm most excited for some of these customers. They had use cases where the schema would break, right? When you sign up for your first savings plan, or you decide to try out cost allocation, split cost allocation, or you add new cost allocation tags, each one of those things will add columns to your CUR, and it grows and grows and grows. And next thing you know, you're staring down a 500 column, multi-million line data set, and the schema is flexible, and some customers want that predictability, and CUR 2.0 gives you a couple of levers. Like there's not only like the ability to control what columns show up in there, that's nice, but also the move from these like one column per resource tag to the resource tags column with a JSON map, similar to like what we had just shown today with the attachments and some of the other stuff. So working with like some of that nested data is going to be a little bit of a change for folks, but I think you're going to enjoy not having 500 columns to dig through to find resource tags. Right now, you can look at all the resource tags in one column. Just
save me scrolling. Like that's the main thing.
Well, now the value is a mile long
true.
If you have them all, but it's still a nice. It's an easier way to kind of consolidate what's going on there. So
100%. And I'm just a big fan of the names. I feel like part of the reason I originally built the optimization data collector stemmed from the organization data collector, which was just getting the organization OUs and names. You still can't get OUs, but the names are like a big thing, because I feel like we talk about is that you had to like memorize it, and we're joking about memorizing numbers. I think I still know some of my old numbers from my old company because I said you use them so many times. Anyway, that has been thank you so much, Justin, for taking us through the IOPS stuff. I cannot wait to kind of talk to some of my customers about this, and hopefully you guys will be able to try some of this too. If you did learn something and find something out and actually use the stuff we're going to show, please let us know at costoptimization@amazon.com. Go on.
If you save money, I would love to hear about it. I think it's always interesting to hear where some of these gaps are for folks. And if you stumble across some like crazy over provision volume, I'd love to hear about it.
Oh yeah, do. And it doesn't have to be exact numbers, it could be percentages, but just because we're like really interested, because there was mention of a product feature request, the more information we have of customers doing this, the more we can try and make it an official guardrail so that others don't have full prey to it. Anyway, thank you so much, Justin, for joining me. Thank you everyone for watching. We will see you next week. Bye.